Also goes for props. If no one shows up in the first 15 minutes, we can leave.
Has that ever happened to you?
No. I have had times when like only 2 people show up though. And you're like, it's like, what do you guys want to do?
This is balls in your court.
Yeah. Like, want to go home and read these sections alone, or want me to just
You want me to just
read them to you? Yeah, that's the only option. Let's see if I can move these over here. Okay. Oh my goodness. I was looking at our schedule. We really only have, I think, today and 2 more like teaching days, and then that's it. Because we're doing, so teaching next Tuesday, and then we've got the review class on the Thursday, so that doesn't really count, well, as teaching, review, and then we've got the test. What, another test? We just had one. I know, crazy, right? And then, no, your final could. And then we do mortgages for a day, and then 2 final exam review sessions. What?
When is the last? What's the last week of classes? I don't know.
December 6th is the last day of classes. Just finishing chapter 6. Yeah. Yeah. So, anyways, so I had a minor heart attack when I realized that. But we're on track. It's just, I'm gonna miss you guys. Oh, well. I always do. Oof. I had like a quarter of a cup of coffee and now I've got the jitterbugs. It's like, yeah, my fingers are like, wow. I don't usually drink coffee, so I'm like, ugh.
In the morning? Wow.
I do have tea though, but or not. So last day, right, we started annuities and we talked about what annuities are, right? Annuities are just when we've got these regular payments coming in or coming out, right? To pay off a loan, for example, right? You've got your car payments for some amount of time, or to save into an RRSP, for example, until you retire or something like that, right? So just regular payments going in or going out, preferably going in, I guess. But usually it's going out like a loan, right? So we talked about how do we set up the timelines, right? And then we talked about the different types of annuities that we'll be making our way through, right? And so we said annuities, well, let's just talk about what an annuity is. Regularly scheduled payments for a specified term, right, until you've paid off a loan or until you've reached a savings goal. Okay. So we said that we can have ordinary annuities. An ordinary annuity, that's just when the payments are made at the end of the payment period, right? So that's going to be the default. And then we said that an annuity due is when the payments are being made at the beginning of the payment period, right? Which means we have to adjust for that little bit of extra interest that we earn by putting it in at the beginning of the month, let's say, instead of at the end of the month, right? And so if you have a peek at your formula sheet, right, that's the only difference between just the left-hand side and the right-hand side. The right-hand side is all your annuities due, right? The only difference really is the 1 plus I tacked on to all these formulas in one way or another, right? And so that's just adjusting for that extra little time frame where it sits in the bank or you borrow it for, right? So an ordinary annuity is when the payments are at the end of the payment period. And then we said an annuity due is when payments are at the beginning of the payment period. Payments are at the beginning of the payment period. And then another layer that we added was we can either have simple annuities or general annuities. So simple annuities are where the compounding frequency and the payment frequency are the same, right? That simplifies things, right? Because we don't have to adjust the compounding frequency, but usually we'll have a general annuity where we can't change the payment frequency, right? We want to make payments weekly or monthly, right? So we're not going to change the payment frequency, but let's say we're compounding quarterly, right? We'd have to change that to match our payment frequency, right? So that's a general annuity, and we'll get to those today. So simple annuities, that's kind of where we started. So a simple annuity is where the payment frequency equals the compounding frequency. And then we have a general annuity is of course where the payment frequency is not the same as the compounding frequency. So we also talked about how do we convert from one compounding frequency to another compounding frequency. We snuck in some fun facts about the effective rates, right? But at the end of the day, we're just going to use the I2 formula that we developed. Okay? So, or mostly. Okay, so we learned how to convert from one compounding frequency F1, put in brackets, to a new compounding frequency F2. So if we want our compounding frequency to match our payment frequency, right, F1 is going to be our original compounding frequency and F2 is essentially going to be our payment frequency, right? And we said, okay, we can use I2 is 1 plus I1, the original periodic interest rate, to the power of F1 over F2, all minus 1. And then we said, okay, we talked about ordinary simple annuities. Simple annuities. Ordinary because the payments are at the end, right? Simple because the compounding frequency is the same as the payment frequency, right? We said we can use the future value is the PMT. It's kind of a big formula, but if you look at it, there's not that many components, which is nice, right? 1 plus I to the power of n minus 1 over I. Where n, remember, is the number of payments, right? For annuities, it's the number of payments. It seems like we're doing a big change, but we're not actually, right? Because the compounding frequency has to be the same as the payment frequency. So n is actually the number of compoundings as well as the number of payments, but now we kind of change it to talk about the number of payments instead. So where n is the number of payments. I'll just throw in that we can still use that formula for n, right? N is time times the frequency, but because n is the number of payments, right, the f we use has to be the frequency of the payments, right? So we can still use that formula, but we have to remember, okay, f has to be the frequency of the payments. Right, that's the only difference. And time is, of course, time in years. That'll never change. Okay. So then we talked about, okay, the future value and the present value, they're not in the same formula anymore, right? And if you think about it, if you have a future value in this type of situation is if we're putting money towards some savings, right? So we're making regular contributions. In the end, we have some future value. What did you start with? 0, right? Present value would be 0, right? So that's why it doesn't go in there, right? Same thing as a present value. A present value would be if you're paying off a loan, right? You got some present value loan amount, right? And then you're making payments to try to pay it off. What's the future value? 0, because you paid off your loan, right? And so that's why they're kind of discombobulated in a way, right? But we can use the present value formula is the PMT times 1 minus 1 plus I to the negative n all over I. Yeah, the negative n. It'll get you, but it's important. I think I made more of a mess. Tried to clean up my end, but yeah. So that's where we left off. We did some examples. So now, any questions before we start 6.3? Cool. So 6.3, we're just going to talk about how do we calculate PMT, right? And how do we calculate N, or the number of payments, which would be our gateway to finding how long it's going to take to pay off a loan, or how long is it going to take to save up some amount. Okay. So calculating the periodic payment PMT and number of payments. N. it depends on whether we know the future value or the present value, right? There's no formula for PMT on your formula sheet, but that's because either of these will have it, right? So we can substitute all the information that we know, right? We'll either know the present value or the future value. We'll know N and we'll know I, right? And then we can plug those in and solve for PMT in either situation, right? And so it depends on if you know the present value or the future value. But then you can just solve for PMT, which I think if I gave you a problem and said, here's the future value, here's the number of payments, here's I, you would probably just say, oh, okay, I have to use this formula to solve for PMT. I think that would kind of come naturally, but we'll say it anyways. So solving for PMT. If we know the future value, plug in all the given values into the future value is the PMT times 1 plus I to the N minus 1 over I. You'll have these memorized in no time. And then solve for PMT. Kind of goes without saying, but same for the present value. If we know the present value, use the present value as the PMT times 1 minus 1 plus I to the negative N over I. And just to highlight future value, present value, present value. Right. So nothing groundbreaking. Let's do an example. We'll do example 212. Whoops. There. Your RRSP goal is $300,000. That sounds nice. The current interest rate for RRSPs is 8% per year, compounded annually, and you intend to retire in 30 years. How large should your year-end contributions be? So here, what I want you to get in the habit of doing is just first checking, okay, when am I compounding, right? What's my compounding frequency and what's my payment frequency? Right here, they're going to be the same because we haven't gotten into general annuities, but on the test for sure, there's going to be general annuities. So you have to make that switch, right? So it's good to just get in the habit of checking, let's say compounded annually, and I'm making year-end contributions, right? So annual contributions, annual compounding, right? We have simple annuity. Okay. So we can say, okay, well, let's start with our timeline. Remember our timeline for annuities, right? We're not going to do 30 ticks for 30 years. That's crazy. But we are going to do the 2 end ticks and then 1, 2 in the front and then 1 in the back. So 5 ticks is what I want to see on your timeline. Dots in between, right? Just to show that, hey, this happens for however long. So you want to retire in 30 years. So here we've got 30 years, making this one 29 years. And then here we've got 1 year, 2 years. Oops. We don't know the payment amount, right? That's what we're, how large should your year-end contributions be, right? But we can just say, okay, well, I'm gonna deposit PMT here, PMT here, PMT, PMT. And these are all gonna funnel into some future value of 300,000. Right. I do like to say that I highlight that I know that this is a future value. It's also a good reminder for when you're picking formulas, right? So of course, anything on this side of the arrow is a future value. Any arrow going this way is a present value, right? And so here I just say, you could have just said 300,000, that's fine. But just, I like to remind myself that, hey, this is a future value. Future value is the one I know. Right? And on this arrow, we're going to put how many payments we have. N is 30. Right. If you want to, you can say N is time times the frequency. 30 years times a payment frequency of 1 is still 30. Just to highlight that we're using that same formula for N, so we're not just pulling it out of nowhere. Okay, so we've got our R is 0.08, and our compounding frequency is 1. And just because I'm a sucker for completeness, I is R over F, which is 0.08, over 1, which is 0.08. If you just jump to the 0.08, that's fine too. I just always show the same steps, even if they're slightly redundant. Okay. Cool. There's our complete timeline. Any questions so far? Neato burrito. We know our future value, so we have to use our future value formula. Future value is PMT 1 plus I to the N, well, minus 1 over I. So we've got a future value of 300,000. We're trying to solve for PMT. 1 plus 0.08 is our I. N we said was 30 minus 1 over 0.08. One plus 0.08 to the power of 30 minus 1. I'll just make sure, I'll write down kind of an intermediate step here, just so you can check your work. 9.062656889 over 0.08, but I don't expect to see that. I'm just giving you something to check your work against, divided by 0.08. So we have PMT times 113.2832111. And these are equal to 300,000. So now our payment amount must be 300,000 divided by 113.2832111. So my contributions, my annual contributions must be 2,648, oops, skip the 8, 0.230016 Therefore, the year-end contributions must be $2,648.23. Nice. I'll just say see example 213 for an example using the present value instead. We're not going to go through it. It's the exact same thing. We've got other fish to fry. So see example 213 for an example with the present value instead. So let's talk about calculating the number of payments. The number of payments. And so you've noticed, right, taking up lots of room on your formula sheet, you have two formulas for N, and that just stems from having a formula for the future value and a formula for the present value that we've rearranged depending on which one we know again, right? And so this is not something that I would expect you to be able to derive, right? Although you can, but not something that I expect you to, right? But just being able to use the N formula. Right? Yeah, that sounds mean. No, I'll only do ones that we've derived in class on the bonus. How about that? And I'm not deriving this. Not now, not ever. No, probably later. Now I'm curious. Okay, so we've got our formulas, right? But depending on, so if we know the future value, we use N is the log, the natural log of 1 plus I times the future value over the PMT over the log of 1 plus I. Just highlighting here the future value and the future value, of course. And then if we know the present value, bless you, we use N is the negative log of 1 minus, right? Yeah. I times the present value over PMT, bless you, over the log of 1 plus I. Oh, changed colors halfway through. Whoop. Guess I should highlight these. These are, of course, on your formula sheet. Pink and purple. Can't really tell on there though, but whatever. So not much to explain around this. Just know how to use them. So let's do example 216. Oh yeah, this one sounds just like a bad idea overall. Maxwell borrowed $20,000 from loan shark Alec. Alec demanded year-end payments of $3,500. how long will it take to pay off the borrowed money if Alec charges 17% interest compounded annually? So how long is it going to take to pay this off? Spoiler alert, a long time. So, but let's see here. So the first thing we're going to check, right, is our compounding frequency and what's our payment frequency. Right, so we're compounding annually and we're making year-end payments again. Right, so they're the same, so we don't have to make any adjustments. Right. So we can go ahead and do our little timeline here. So starting today, and then for some amount of time, we don't know how long, right? That's the whole problem we're trying to solve. How long is it going to take to pay these off, right? But we know at the end of the year, so 1 year, 2 years, n-1 years, and n years, right? Helps that the payments are annual, right? That's why it's n. And we're gonna have to first find n in order to find t. N and t will be the same because we're paying annually, right? But sometimes it's not. So we're making payments of 3,500, bless you, 3,500. And all of these, right, are going towards paying off a loan that he got today. So a present value, a loan of 20,000. And I'll just say n equals question mark. I don't know. Stop having fun out there. We're only allowed to have fun in here. So we've got R is 0.17 and our frequency is 1. I is R over F, which is 0.17 over 1, which is 0.17. It's like a compulsion. Can't help it. Show all the steps. Okay. So we've got our I, and now we can just get to work. So we know our present value, right? So we have to use the formula with the present value in it. Okay. So we use n is the negative log of 1 minus I times the present value over the PMT over the log of 1 plus I. So n is going to be the negative log of 1 minus 0.17 times the present value of 20,000. I'll put brackets around. Don't have to, but 20,000 over the payment amount of 3,500 over the log of 1 plus 0.17. So we've got 20,000 divided by 3,500 times 0.17, and then 1 minus that, right? Careful there. So I'm just gonna write down these intermediate steps again, just so you can check your work. The log of 0.028571429 over the log of 1.17. So now if you take the log of this big decimal in the numerator, you'll see why we need that negative in front, right? It's to cancel out the negative that we get from the log. No. Just hit the log, no negative. But then you'll get negative 3.555. So it's going to look like this. So negative 3.555348061. Store that. And then 1.17 log over 0.157003749. Right. So this is the only reason that we need to have this negative here, right? Because we can't have negative payments, right? If we didn't have it, right? We'd have negative payments, which doesn't make sense. So we just need to get rid of that negative. Right? That's all that's happening there. So now we do recall 1 divided by that answer. Oh, I think I messed up. There we go. 22.64498834. Oops. Random bracket. Do you think Loan Shark Alec would be okay with 22 payments?
No.
Probably not. So we'd have to go for a full 23 payments, right? For N, we always have to round up. Payments per year, 23 years. Yikes. Hope it was worth it. Maxwell. They should be more specific with what they bought. I like the backstory. Yeah. This one here. It's the 1 month. So I just went 20,000. So you have to do the here. So the 20,000 divided by 3,500 times 0.17.
Is it multiplying or
But then multiplication here. Yeah. And then 1 minus. That'll do it. No problem. Okay. So, oops, no text. All right. For N, right, even if we got 22.01 for our N, we would still have to round up to 23, right? Because 22 wouldn't quite get us there. Guardo. There we get it. Guardo. We would need to make N equal to 23 payments. Right. Just for completeness, right? N is time times the frequency. Right? 23 payments in time, right? Remember, this has to be the payment frequency, which is just 1 in this case, right? Yearly, right? At the end of each year. So time is 23 years. Let's think about it this way. If it takes him 23 years, he would have paid 23 times 3,500, right? That's how much he's paying. $80,500 to borrow $20,000. That's a great deal. And that's why you should always go to Loan Shark Alec. You don't have to throw in how much he pays and all that stuff. But I think it's good to think about it from that perspective, right? So we're making payments, okay, but we're always paying off more than what we borrowed. Yeah, a tough amount. That's an extreme example. Yeah, I mean, I think if you've got that kind of interest rate, you'd probably buckle down and pay it off a little bit faster, maybe. Hopefully. Yeah. Yeah. So you want to pay it off quickly. All right. Cool. Cool. So, are we ready for some general annuities? I think you are. Nothing changes except for in the beginning, right? When we're checking, we're going to find that the compounding frequency is not the same as the payment frequency. And so we have to make that little adjustment. But once we have, then everything is the exact same as what we've been doing. Right. So 6.4 is on ordinary general annuities. Once we've done this, right, the only difference between chapter 6 and chapter 7 is going to be that maybe the payments are being made at the beginning of the month, the beginning of the year, right? And then we use a slightly different formula, but the ideas are all the same. So that's why I love getting into this stuff, because it's like more of the same. It almost gets boring once you know what you're doing. Oh, on that note, I posted a little Moodle quiz. It's due a week from now. I think it's like 5 questions. I know, right? Test not on Friday because we don't meet on Fridays. Test on Tuesday. Yeah. Following Tuesday. Yeah, 27th. Yeah, right to the end. I know. But on the bright side, it's only on chapter 6 and 7, right? And once we're done test 3, then you'll basically have seen everything except for mortgages that'll be on the final. So that's pretty good, right? In a test situation. All right. So ordinary general annuities, let's brush up on what they are, right? So now payments are made at the end. Of the payment period still. And the payment frequency is not the same as the compounding frequency. So what we've said, right, is that we will have to adjust our compounding frequency to match the payment frequency. Right? So I'll just make a note of it again. And it's probably a good idea to just always try to convert the compounding frequency to match the payment frequency. If they're the same, then you can say, oh, I don't need to do that, right? So it's good to just try to do it all the time. And then if you don't have to do it, then you can skip that step instead of forgetting to do it and it messes up all your calculations. So if the compounding frequency I'll say F1 is not the same as the payment frequency, F2 we need to convert from I2, or from I1, sorry, to I2, right? And we use I2 is 1 plus I1 to the power of F1 over F2, all minus 1. So that's why we worked with that formula initially, right? This is the first time that we'll need it, but we're going to need it a lot, so. Then use I2 as our I in the formulas we've already developed. Already developed. Okay. What would it look like if we had a simple annuity, right? Where F1 is equal to F2, right? What would happen to our formula? Say F1 equals F2, right? A simple annuity like we've been doing. Exactly. Then you'd have I2 is 1 plus I1 to the power of F1 over F2 minus 1. That's just going to be 1 plus I1 to the power of 1 minus 1. This will just be 1 plus I1 minus 1, which is just I1. So there's no point in doing that calculation because you'll just get back to where you started. But if you want to play it safe and always try to convert to I2, that's fine, right? It's not going to hurt anything. Just a little bit more work and you'll just end up at I1 anyways. Right? So they're the same. Okay. All right. Armed with this extra bit of knowledge, let's go to example 218. Suppose month-end payments of $300 are made on a car for 4 years. If the rate of interest is 5% per year compounded quarterly, what is the value of the car? So we're compounding quarterly and we're making monthly payments, right? So we're just going to make a note here that F1 is the compounding frequency, which is 4, and F2 is our payment frequency, which is monthly, so 12. You'll know which one is F1 and F2, right? Because we can't change the compounding or the payment frequency, right? So we have to change our compounding frequency to our payment frequency, right? So we have to move from F1 to F2, right? So that's how you're going to remember which one is which. Okay. So then we have to convert, but first we can say, okay, well, my rate 1 is 0.05. And we know F1 is 4. So I1 is R1 over F1. 0.05 over 4. 0.0125. Right. Phew. Oh. So that's our I1, but we have to find I2. I2 is 1 plus I1 to the power of F1 over F2 minus 1.
F2 is always going to be the compounding, and then F1's the payment.
Other way around.
F1 is
the compounding.
F2 is payment frequency.
That's right.
Okay.
Yeah. Nice. So now we've got 1 plus 0.0125 to the power of 4 over 12 minus 1. So I get plus 1 to the power of, and I put my 4 over 12 in brackets. I don't think it matters, but I have never tried not to, so I'm not going to start now. Okay. Yeah. Oh yeah, hit the equals button.
Oh, okay. 1.0125 to the power of.
I'll write down where I get to, and you can check. 0.004149425. So you'll want to make sure that that's what you're getting, right? This is store worthy. I'll store this in 1 because we have to use it as our I in all our calculations, right? So we have to store it. So make sure that that's the value that you get. So, good. Now we can do our timeline. Right. We could have done it after finding I2 or before finding I2, sorry, but I just like to find I2 and get it over with, right? Just so I don't forget to do it later. So today, and we're making payments for 4 years, but now the 4 years is not going to be our end dot, right? Because we're making monthly payments, right? And so I'm going to write 4 years kind of up above here, right? But how many months in 4 years? 12 times 4, 48 months. Because all these ticks represent your payments, right? And so we've got 1 month here, 2 months, ... 47 months. And then 48 months today. Okay. And we're making $300 payments. And we want to know what the value of the car is. So 300, 300, 300, 300. The value of the car is the loan amount, right? And so this will be a present value. So these are going to funnel back to some present value, which is what we want to solve for.
How do I know I'm looking for the present value and not the after interest paid loan in the future value?
Because any loan amount will be a future or a present value, sorry, and any savings amount will be a future value, right? It's yeah, because we're going to be paying off, right? Paying off some present value, right? But if we were making these contributions, right, going into a savings account, it would become a future value. Yeah. So, yeah, it's very important. So loan amounts are present values, savings amounts are future values. Okay. So we want to find our present value. We have to use our present value formula. So PV is the PMT times 1 minus 1 plus I to the negative n over I. Oh, I forgot to put my n on here. That's how your timelines should work too. Just figure out what's missing and just put it on the timeline if you need it. So n is time times the frequency. Time is 4 years times the payment frequency, which is 12, which we said was 48. So now we've got our payment amount of 300 times 1 minus 1 plus, oh, this big long one, 0.004149425 to the negative 48 over 0.004149425. A lot of fours, just for fun. So, all right, good thing we stored this. 1 plus recall 1 to the power of 48 negative. 1 minus that. I'll do an intermediate step. I wouldn't expect to see any intermediate steps. As long as you've shown all your values plugged in and then the final answer, that's fine by me. I just want you to have something to check against. Times 0.180253653. I think. Let me check. 1 plus recall 1. Yeah, I did. To the power 48 negative equals 1 minus that. Yeah. 0.004149425 divided by recall 1. So 43.44063287 times 300. 13,032.1896. Therefore, the car cost $13,032.19. Pretty good deal. It was a 2002 Sunfire. No, that's the car that I was driving up until recently. Not my car, my husband's car. We drove my car to Ottawa. And I love my car. And he doesn't like it. But he loves his Sunfire. And I hate it. Well, I just bought a different one. I couldn't handle it. I drove it all last year and it was the worst. Anyways, I'm used to automatic windows for one. That's really nice. Yeah. Yeah. Yeah, on one side. Anyways. Can we do these on our calculator with the time value money functions? Yes, we can. Of course. We've seen the PMT button. We just used to fill it in with 0. Now we know what to fill it in with, right? Our payment amount, right? And then we also had our payments per year and our compoundings per year. Right now, those can be different and just internally, it'll just calculate the I2 for us and use that, right? So it saves us quite a bit of time, right? So we can solve this using the time value money functions on our calculator. Oof, things got messy there. So we've already seen the list of values. And so we'll talk about what they are again, right, just as a refresher, and then we'll just redo this example on our calculator, right? So on your test, right, you'll be able to just use your calculator to solve these problems if you want to, right? But you have to show your work properly by listing all the values that you're plugging in there, right? Telling me which one you're going to solve for, that kind of thing, right? But definitely legit. And I think now that we're in annuities, you're going to like it a little bit more. Okay. On the final, there will be, I think, one or, yeah, probably just one where you have to do the annuities by hand, right? So it'll be an annuity question and you have to solve it by hand. The others, if it doesn't specify, you can just use your calculator if you want to, right? So kind of valuable to know. So we have N, the interest per year, the present value, the PMT, the future value, the payments per year, and the compoundings per year. N is the number of payments. Interest per year, remember, is the nominal rate as a percentage. For example, if I tell you 7% compounded quarterly, right? 7%, you have to use just 7, right? Not 0.07. So that's a little bit of a twist. PV is, of course, our present value. PMT is the regular payment amount. FV is the future value. Payments per year is the payment frequency. And the compounding frequency. So we did establish that, okay, any money that's leaving our hands, right, whether we're depositing it at the bank or we're paying off a friend or whatever, right, is going to be negative. Any money to us, right, so any loan amounts that we receive, right, or anything like that is going to be positive. Now it's going to be extra important, right, because if these payments are positive or negative, well, it's either money in the money to us or money leaving us, right? Makes a big difference. So for these little guys, these three in the middle, PV, PMT, and the future value, right? So payments leaving our hands will be negative. And any payments we get will be positive. And remember that the present value and the future value have to have opposite signs. So PV and FV must have opposite signs. So let's do example 218 again. On our calculators. Our timeline would look the exact same, right? But now we're just going to enter all our information. So N, the interest per year, the present value, the PMT, the future value, the payments per year, and the compoundings per year. So N was 48. The interest per year was 5%, so 5. We're solving for the present value, so we're going to put a star there. Right. And then once we've solved it, we can put that value in there. Right. Our payment amount is 300, but we're paying off this loan, right? So it's 300 leaving us. So we have to have negative 300. I'll just make a little side note here. We are making payments. If we're paying off a loan, the future value is going to be 0, right? I'll make it negative 0, but the calculator actually doesn't register negative 0. 0 is just 0, right? And so I'll just throw a negative on here just for kicks, I guess. But also because I want my PB to be positive, right? Because it's some loan amount, right? So just keeping with that same, they have to have opposite signs. I'll give my future value a negative. Yeah.
For these questions where we can solve them, you're allowing us to solve them on our calculators. Do you still want us to draw a timeline?
Timeline, yes. Yeah. So you still have to show your complete timeline, but then how you solve the problem doesn't matter to me. Yeah. Cool. And the payments per year, we have monthly payments, and the compoundings per year was 4. Okay. So for the present value, you're just going to plug in 0 for now and then go back and compute it. Right? So helps to turn it on. We just go ahead and fill these slots. So 48, hit N. Remember, as long as it says N equals 48 on your screen, right, it's registered what you told it. There's no way to go back and check to make sure what it has. Right? Maybe in your memory, but I don't know. Doesn't matter. So just trust it. 5 interest per year, 0 present value for now, 300 negative for the payment amount, 0, I'll try a 0 negative future value. And then we have to get to our payments per year. So second interest per year gets you to the payments per year. Right? And we have 12, hit enter. Because until you hit enter, it just says payments per year with no equal sign. Right? If you're in what I call a second menu, right? So payments per year and compoundings per year are a second menu. You have to hit enter to store stuff. Right? Otherwise you don't, but for this you do. Scroll down to the compoundings per year, change it to 4, enter. And then you can hit second, quit to get back to the 0 screen. And now we can ask it to compute present value. And it says 13,032.18986. What? I'll just highlight our answer here. Nice, right? So even if on the final, right, you're not allowed to use your calculator to answer the question, you can still use your calculator to check your work, right? So, still, huh? Some of them you're allowed to. There's going to be one where you have to show your work by hand. Yeah. Okay, cool. How about another example? 219. Let's do both. So we'll do example 219. First, we'll do it by hand, and then we'll use our calculator, right? Just to get comfortable. Okay. So Tom and Delilah wish to start a college fund for their daughter. How nice. Their goal is to put $200 into the account at the end of each 2-week period, right? So our payment frequency is bi-weekly. Assuming that college fund will earn a rate of interest of 3.75% compounded quarterly, how much will be in the account in 20 years? Right, so now we've got this situation where we have, let's jot it down, F1, which is your compounding. How about this? I'll steal some of the notation, right? The compounding frequency, C per Y, is quarterly, so 4. How about F2? The payments per year, 26, right? Bi-weekly. Okay, so because these aren't the same, we have to adjust our compounding frequency to be 26 instead of 4. Right. We've got our 0.0375, and I1 is R1 over F1. 0.0375 divided by 4. Let's see. 0.0375 divided by 4. 0.009375. So now I can calculate I2. I2 is 1 plus I1 to the power of F1 over F2 minus 1. 1 plus 0.009375 to the power of 4 over 26, all minus 1. So plus 1 to the power of 4 divided by 26 equals minus 1. I get 0.00143662. I'll store that in 1. I'll just keep overwriting my 1, I think. Okay. Now that that's done, let's plot out our timeline. So our timeline today, and they're going to be making payments for 20 years, right? How much will be in the account in 20 years? So 20 years of bi-weekly payments. Remember, these ticks represent the payments. So we've got 20 years. I'll just write that up here. And I don't know, you can talk about bi-weekly ticks, or you can talk about weekly ticks if you want to, and just go by 2s. Which one? All right. So we could say, okay, in 20 years, there's 52 weeks, so 1,040 months, or sorry, weeks. Thank you. making this tick 1,038 weeks, right? You could do that.
These marks if we don't convert the times.
Well, I don't want to see 20 years and then 20 years minus 2 weeks. But if you do 1,038 weeks and 1,040 weeks, or if you want to do, so 20 years times 26, you can do 520 bi-weeklies and 519 bi-weeklies. Bi-weeklies. That's okay. So you have options. But we don't like options. I know. So here, same idea, right? This tick, the first tick would be 2 weeks or 1 bi-weekly. How about we do BW? Or 4 weeks. 2 bi-weeklies. These are all the same. It just depends on how you, because I actually go for the weeks, just because I like to talk in weeks, I guess, not bi-weeklies. So can do kind of, I guess if you wanted to, you could put it in days, but not sure why you would want to, but you can. Okay. So we're making what contribution? We're making $200. Okay. So $200, 200, 200, and 200. Oh, I forgot my ... The funnest part. And we want to know how much is going to be in this account after 20 years, right? So that's going to be some future value. So these are all going to funnel towards some future value. N is time times the frequency. Time is 20 years times the frequency, which is 26, or 520 as we decided. Okay. So we need to find our future value. We have to use our future value formula. So the future value is the PMT times 1 plus I to the n minus 1 over I.
Do we use the new I?
That's right. So once you've calculated an I2, it's going to take the place of I. So yeah, so once you have an I2, that's your I. You can ignore all the others. So now we have a payment of $200 times 1 plus, oh, what was that little nasty recall one? 0.00143662 to the power of 520. Oof. Minus 1 over I, which is 0.00143662. I'm just going to plow through the big brackets all in one go here. Plus 1 to the power of 520 minus 1 divided by recall 1. I get 200 times 772.3 3801,011. Times that by 200. They have a nice $154,476.202. So they will have 154,476.2 pennies after 20 years. How much will they have paid out of pocket? Just out of curiosity, right? They will have paid $200 times 520. $104,000. Not quite Loan Shark Alec in reverse, but it'll do. Okay. How do we do this on our calculator? So on our calculator, we're going to fill in Ann. So you still have to do your timeline, of course, but then to replace the work finding I2 and finding the future value, right, we can just say, and the interest per year, the present value, the payment amount, the future value, the payments per year, and the compoundings per year. So N we decided was 520. The interest per year is 3.75. The present value, right, thinking about a saving situation, they start with 0, right? And so we can do, I'll do -0 just because the future value, right, I'm going to pretend that it's all coming to them. So I want it to be positive. It doesn't really matter, but in this situation, it doesn't matter, but just to get the hang of it. And they're making payments of 200, so they have to be negative payments. We want to solve for the future value. And they're making bi-weekly payments, and I think we were compounding quarterly, right? Yeah. So 520 and 3.75 interest per year, 0 negative present value, 200 negative payment amount. I'll put in 0 for the future value for now. 26 enter for the payments per year, and 4 enter for the compoundings per year. Second quit, compute future value. We get 154,476.0202. Woohoo! Which is the exact same as what we found. Nice. Okay. So let's do one more example, example 220. But we're only going to do it on our calculator. Still with a timeline. solve only with time value money functions. So what would this look like? So Brad has, so he already has 25,000 saved in his RRSP. So it pays 6.8% compounded quarterly. Brad will continue making month-end contributions of $400 until he reaches a savings goal of $450,000. How long will this take? So we have to find N, but then we also have to find time, right? How long will this take? First, we have to find how many payments it's going to require, and then we can go from there. So the little bit of a pickle, and kind of the reason why we just use our calculator instead, is because we have this 25,000 sitting there already, right? And then we're adding on payments on top of it, right? So this 25,000 that we deposit, it's just going to sit there and make some interest, and then we're going to make payments as we go along, right? And so our timeline, start today, and then we go for, let's see, we're going for, well, I'll put time question mark up above here, but we're making month-end contributions, right? So for N months, we're going to be making contributions. So N months, here's N minus 1 months. We have to solve for N. 1 month, 2 months, dot, dot, dot. So first, let's deal with these $400. So he's making $400 contributions for some unknown amount of time. These are all going to add up to some future value. We're also told, right, that he already has 25,000 today. Oops. So that's going to add up to, let's say, future value 1, future value 2. And then the total future value, we're told he's going to stop making payments once he has a total of 450,000. What's nice is we don't have to calculate future value 1 and future value 2. Our calculator can just handle it, right? We just tell it, oh, and by the way, I had 25,000 laying around, and I'm going to deposit that today, right? So, yes. These darn timelines. You do. Okay, cool. So, and interest per year, present value, PMT, future value, and payments per year, and the compoundings per year. So N is the one we're trying to find. And let's see here. We're told that the interest is 6.8%. And while I'm up here, compounded quarterly. So the compoundings per year is 4. So the present value, instead of starting with 0, he's actually starting with 25,000. How I want you to think of it is he is taking that 25,000 from underneath his mattress and he's putting it into this account, right? So even though it says it's in there, I want you to think of it as him putting it into the account, right? So exactly, so that's negative. And he's making regular payments of $400. And now, right, at the end, he's going to be able to withdraw $450,000. So future value, the total future value is $450,000. And he's making payments, monthly payments. Nice. So now, here we go. Put in 0 for N for now, 6.8, 25,000 negative present value, 400 negative payment amount, 450,000 future value, 12 payments per year, 4 compoundings per year. Compute N. I get 301.0327127. I'll just highlight that that's my answer. Okay, yeah. Yeah. So it has to be negative because it's working towards the future value. A positive 25,000 would mean that he first took out 25,000 that he then has to pay back first, right? Exactly, yeah. Cool. So we can't just do 301. We have to do 302 payments. Right? We need to make N equal to 302 payments. Right, but N is time times the frequency. 302 is time times the payment frequency, which is 12. So time, we don't really think well in 302 months, right? So 302 divided by 12, that's 25.166 repeating years. It would take 25.17 years. Let's see. Cool. Nice. So I'm not gonna take it back or mark it or anything, but it might be a good idea to try 6.7, which is the self-test for chapter 6, right? Kind of over the weekend, right? So try 6.7, which is the self-test for chapter 6. There's also question 4, which I think is pretty funny. Let me read it to you. As of Albert's 56th birthday, he has accumulated $195,000 in her RSP. He has ceased contributions, but will allow the RSP to grow until she reaches an age of 65. Lots of typos, but like consecutive typos. Funny. Anyways, so have fun with that one. There's going to be a practice test, yeah. Same idea as before. You do it for the review class and then, yeah. Cool. All right. See you later, alligators. We are.